Hello again and welcome back. For this video we're going to talk about the division property of exponents. You can see our goals here. Find the quotients of monomials, and of course you have to watch the other video to know what monomials are. Find the power of quotients. Okay, so when we talk about quotient of powers, quotient of course is the solution to a division problem. So we're talking about dividing of powers, division powers. So our first example here, we have 2 to the 8th, it's going to be divided by 2 to the 3rd. Important key here is to note that both of these bases, they're exactly the same. This rule only works with the same bases. So if we expand 2 to the 8th, we get 8 2's here at the top, and then we expand 2 to the 3rd, we get 3 2's at the bottom, but every 2 on top cancels with 1 on bottom in terms of becoming a 1, and 1 times anything is an identity, so it cancels out. And then the second 2 cancels, and then the third 2 cancels, and you can see all we have left over here are 5 2's. So 1, 2, 3, 4, yeah, there's 5 of them there. And that, of course, can be rewritten back as 2 to the 5th. So what's the shortcut to dividing quotients or using quotients of powers without expanding them like this? So here's the quotient of powers rule. To divide two powers with the same base, again, it's got to have the same base, you subtract the exponent, so it's going to be top minus bottom, and you keep the same base. So if we have a to the m divided by a to the p, again, it's got to have the same base of a, then that's equivalent to a to the m minus p. Notice it's the top one minus the bottom one over here, not the other way around. So b to the 12th over b to the 9th, although we could calculate those individually and divide, it's much easier to just call it b to the 12 minus 9, which is b to the 3rd. Okay, so we got a couple of examples here for quotients of powers. They want us to simplify and assume that denominator does not equal 0, because you can't divide by 0, so the values that are in the denominator are not allowed to equal 0. All right, so what we're supposed to do is rewrite this as b to the 5th over b to the 2nd times c to the 7th over c to the 1st, and we'll rewrite those. So the first one here is going to be b to the 5 minus 2 times, and I've got c to the 7 minus 1, and that should give me b to the 3rd, and then c to the 6th, and that's the final simplified solution. We'll do the same thing on the bottom. So the first one is going to be a to the 2nd over 1, because there's nothing down here that matches a, times b to the 9th over b to the 8th, times c over c times d to the 4th over d to the 1st. Now this first one is just going to be a squared, because a squared divided by 1 is a squared. The second one, b to the 9th over b to the 8th, again is b to the 9 minus 8, which is just b to the 1st. The middle one here, c to the 1st over c to the 1st, is going to give me c to the 0. Well, a number divided by itself is 1, so this becomes a 1. That basically just drops out of the problem because I don't have to times by 1. And then this last calculation, d to the 4th over d to the 1st, leaves us with d to the 4 minus 1, which is 3. So our final simplified solution will look like this. Okay, so now they want us to apply the divisions of powers. So at sea level, there are about 10 to the 25th molecules in a cubic liter of air. In the stratosphere, that's way up about 30 kilometers. The same cubic liter of air has about 10 to the 23rd molecules. Since the exponent is smaller, that means there's less air molecules the higher you go. Approximately how many times as many molecules are there in air at sea level as there is in the stratosphere? Now you got to be careful here because it sounds like you're multiplying. It says how many times as many. It's like saying how many times is big or how many times bigger. It's actually a division problem. And we want to take the sea level here. How many times as many are there in sea level as there is in the stratosphere? So we're taking sea level of 10 to the 25th power, and we're going to divide it by the stratosphere, which was 10 to the 23rd power. If we use the power rules here, the quotient rules, 10 to the 25th over 10 to the 23rd is 10 to the 25 minus 23rd power, which is 10 to the 2nd power. Now if we expand that into what it's actually evaluated out to, 10 to the 2nd is 100. What that means is there is 100 times more molecules at sea level as there are in the stratosphere when you're 30 kilometers up. Okay, for this next one, we got power of a quotient. This is similar to power of a product rule. Remember, power of a product rule, we can distribute the exponent. Well, when we do power of a quotient, we can also distribute the exponent. So the way that this works out, you see this first one here says 2 to the 5th, but the whole thing is raised to the 3rd. That means show us 2 to the 5th as a factor 3 times, so that's what they did. If we combine them together, you'll see we've got 2 times 2 times 2 in the numerator, which is really 2 to the 3rd. And 5 times 5 times 5 in the denominator, which is 5 to the 3rd, which really means, if you look at these over here, that's really saying this 3 distributes to the numerator and it distributes to the denominator. So here's the actual power of a quotient rule. To find the power of a quotient, find the power of the numerator and the power of the denominator. So you're finding them separately. So a over b raised to the mth powers, remember there's a 1 here and a 1 here, you can distribute it. 1 times m is m, and m times 1 down here is also m, so you end up with a to the m over b to the m. We can do the same thing with actual numbers. So right here we got 1/4 raised to the 5th. When I distribute that 5th power to both these, I get 1 to the 5th on the top, 4 to the 5th on the bottom, and of course these could be simplified a little bit further if you wanted to. Same thing with c over d raised to the 6th. We just distribute the 6 to both the numerator and denominator and then keep simplifying as we move on. All right, so we got power of a quotient. Let's do this quick example. So this 3, remember these have 1s on them. The 5 and the 6 have a 1 on them. The a has a 2, so this 3 is going to be distributed here. So 5 to the 1st times 3, that's power to a power rule, times, and then I've got 3 distributed to the a, so a to the 2 times 3 power, over, and then I'm going to take the 3 and also distribute it to the numerator. So that gives you 6 to the 1 times 3. So our final solution would be 5 to the 3rd, a to the 6th, over 6 to the 3rd. Now, if you want to simplify these things a little bit further, you could take this 5 to the 3rd power and call that 125 a to the 6th. And of course, the 6 to the 3rd could also be simplified to 216. Okay, power of a quotient with variables. I think we just did this. Again, we're assuming that the denominator cannot equal 0, can't divide by 0. So the first thing I'm going to do is distribute this power of 2 to the power of x to the 4th. So that's going to be x to the 4 times 2 times, and then there's a 1 on the y, so distribute that, and I get y to the 1 times 2. Draw my fraction bar. And then I'm going to distribute the 2 to the x on the bottom, so that's x to the 1st times 2. And then we've got a y to the 1st, so it's y to the 1st, and then when I distribute the power, I get a times 2. And I also have a z down there to the 1st, and I distribute the 2 to the z, and I get times 2 there as well. When I simplify this a little bit further, I get x to the 8th on the top from this one, y to the 2nd. On the bottom, I get x to the 2 times 1, which is 2, and y to the 2 times 1, which is 2, and z to the 2 times 1, which is also 2. Now, we don't want to stop here because we also have variables in the numerator and the denominator. So I want to take my x to the 8th over x to the 2nd, reduce that. Y to the 2nd over y to the 2nd, reduce that. And since I don't have a number for the z, okay, so I'm going to just put a 1 in the numerator. And then I'm going to simplify these. So this right here becomes x to the 8 minus 2, which is x to the 6th. This one right here becomes a 1. A number divided by itself is 1, which means it drops out. Okay, so this is actually over 1 times, and then there's nothing to simplify here, so 1 over z to the 2nd. So the final answer here is when you multiply them back together, you get x to the 6th over z to the 2nd, because these 1s are no longer needed. They're just for identity purposes.